Okay. The next thing that we're going to talk about is the error type. While doing hypothesis, some of the project leaders, quality professionals tend to make certain errors, which is something which we are going to understand and learn so that we should not make those errors. The first, to understand that first, we would like to know what is a p-value here. P-value is referred to as a value of significance. P-value is a decision criteria for acceptance or rejection of the hypothesis. In the previous slides, we discussed about different types of hypothesis, which is null hypothesis and alternate hypothesis. However, we did not discuss that how do I identify whether it's a null hypothesis or alternate hypothesis. With the help of p-value, I define whether it is a null hypothesis or an alternate hypothesis. With the help of p-value, as I said. What is p-value? Let's understand it. It's a probability value which varies from 0 to 1 and denotes the contribution of chance in any relationship. The commonly used p-value is 0.05. Okay. When my p-value is lesser than 0.05, in that case, I would say it's an alternate hypothesis, which means X has a significant impact on Y. When my p-value is 0.05 or greater than 0.05, then in that case, I would say it is a null hypothesis. Okay. So to understand it better, let's get into the detail. So there is a analogy that we use, or there is a memory jogger that we use to understand. When p is low, null will go. When p is high, null will fly. Okay, so that's how you'll be able to remember. So when p is low, which means when the p-value is less than 0.05, null will go, which means we will reject the null hypothesis and accept the alternate. When the p is high, which means if the p-value is greater than 0.05, null will fly, which means we would accept the null hypothesis, and which means it's not a significant. Now I would refer to the different error types that we're going to understand in the hypothesis testing. First is the alpha error. It is also known as type 1 error. When the null was true, null is also denoted as HO. Okay, and you choose alternate. Alternate is also denoted as HA, which means there is no significant impact between two different variables, but I mistakenly choose as an alternate and started working on it. That's a kind of an alpha error. The second type of error, which is known as beta error, wherein alternate was true, which means one of the X has a significant impact on Y. However, I did not choose that. I ignored that and I did not work on it. So that's why it is very, very important to ensure that we do not make any of these errors, neither alpha error nor beta error. And the only way to ensure that we don't make an error is to keep a note of each and everything that we are referring. If we are going to do certain tests, we are going to make a note of it, because sometimes when we don't make a note of it, we tend to make those errors. So if it's a null hypothesis, make a note of it that this cause has got null hypothesis and this cause has an alternate hypothesis. So alpha error is when, as I said earlier, when you choose HA and HO is true. Beta error is when you choose HO when HA is true. And let me tell you, alpha error is also known as type 1 error and beta error is also known as type 2 error. Now we are going to talk about different types of tests that we do in the Six Sigma, which is hypothesis testing. And these tests will depend upon the type of the data that we have. And type of the data means whether it's a continuous data or a discrete data. Okay. We will talk about these tests as an overview of in which particular situation which test is being utilized depending upon the data. However, in the black belt program, we do these tests on many tests. Okay, so let's talk about the first type of test. If my y is continuous and if my x is also continuous, I do two types of tests, which is regression and correlation. Okay, so while doing the hypothesis testing, I would, if I get a combination like y continuous, x continuous, I will go for a regression and correlation. Okay, so you can take any example where my y is continuous and my x is continuous. So my y continuous could be the cycle time, and my x continuous could be the age of the person, the tenure of the person, the salary of the person, uh, etc., etc. Okay, so when y continuous, x continuous, in that case I would do, there are two things that I can go for. Either I can go for a regression analysis, and second is I can go for a correlation analysis. The second category is if my y is continuous and my x is discrete. In that particular case, I would be able to go for two-way ANOVA and journal linear model. Okay, so there are two types of tests that I do in the y continuous x discrete. However, in this particular category, we look at two types of stages. One is the variation and another is the centering. Let's understand that in detail. Variation is when I am able to meet the customer requirement. For example, if I have a productivity, one of the key metric in the organization, I've been able to meet it, but there's a lot of variation every month. Though I'm doing good, if my productivity target is to produce 1,000 units in a month, okay, I'm doing 1,500, sometimes I'm doing 1,200, every time meeting the target, but there's a lot of variation, and variation is always not good for the process. So in the Y continuous X discrete categories, we look at whether it's a variation issue or a centering issue. Centering issue is a issue wherein we are not meeting the customer requirements for which we're doing a project. So as you know, in Six Sigma, we not only study the variation, only study the centering, we also work on the variation. So in case of Y continuous X discrete, and if I'm looking at the centering, and if my data is normally distributed, I would do three kinds of tests depending upon the situation. If I have one variable only, then I would do a one sample t-test. If I am comparing means of two different variables, then I will go for two sample t. And if I have more than two samples to compare, more than two axes to compare, like uh, regions, region A, region B, region C, zone A, zone B, zone C, then I will go for a one pair one. But this is only when my data is normally distributed. However, under centering, when my data is not normally distributed, then in that case, I have options like one sample sign test for one subgroup, Mann-Whitney for two subgroups, Moore's median for more than two subgroups. In case of variation, I do a test called test of equal variance. In case of normal, I go for Bartlett. When there are two subgroups, for more than two subgroups, I go for F test. And in case of not normal, no matter whether I have two or more than two subgroups, I go for Levine's test. Okay, so these are the different tests that I do for Y continuous and X discrete. If my Y is discrete and if my X is continuous, in that case I will do a test called binary logistic regression. It depends upon the data that I'm looking at. If my Y is discrete and my X is also discrete, in that case I would have a test which is called chi-square test. In that case, my Y and X both are discrete in nature. So I have two options under chi-square. I would do goodness of fit and independence test. So this is an overview of the different types of tests that we do depending upon the type of data, depending upon the combination that I have. And with the help of this tool, I would be able to derive to a conclusion whether this particular X has a significant impact on my Y or not. Because till now we were just focusing on whether this X is impacting or not. But in Six Sigma green belt or black belt projects, it is very, very important for us to look at whether it is a significant impact or not. And significance can only be checked using the hypothesis testing, using this test, which will be done with the help of these tests. So I will not get into the detail. I will not get into to the Minitab version because these tests are to be done in the black belt, because which is a next level for you. Now I would like to introduce you to the 7 tools of quality. These are called the 7 golden tools of quality, which are very important in the Six Sigma, Green Belt, Black Belt, or any of the programs that we go for. Uh, the term 7 tools of quality is named after the 7 tools of the famous warrior Benkei. Benkei owned 7 weapons which he used to win all his battles. Similarly, as per the standard, we will be able to solve 95% of the problem using these 7 tools of quality, which are medium impact in nature. However, if I want to solve the high impact problems, I will have to rely on the tests that I have just learned, understood in the previous slides, which are the hypothesis testing in different. But in case if the problem statement is medium in impact, then in that case we recommend only the 7 tools of quality. So let's see what are the 7 tools of quality that we have here. The first tools of quality, which is known as the Pareto analysis. The second is known as histogram. The third tool, which is known as the scatter plot. The fourth tool, which is known as cause and effect or fishbone, which we have already covered. The fifth tool is known as flowchart. The sixth tool is known as check sheet. The seventh quality tool is known as control chart. And there is a new one in the edition which is called the stratification, which is also known as the tools of quality. Although we still not call it as a 8 tools of quality because it has become a standard from Benkei because he owns 7 weapons. But stratification is also one of the tools which are being used to solve problems, to analyze the data, which we will also be going to talk about.